Hello, my name is Alwyn Joseph, and I'm here to answer this question for the video assignment 2A. So the main question is, a car traveling at 35 meters per second suddenly runs out of gas while driving up a 7-degree incline. We have to find how long it will take for the car to stop after it runs out of gas, and how far it will travel before it stops. So what we know currently about this problem is that up until the car runs out of gas, it is going at 35 meters per second. That's going to be the initial velocity. And what we also know is what we have to find the time and the distance at when the velocity becomes 0 meters per second. Because we're finding it for when the car stops completely. So we have V final equals 0 meters per second. We also have the acceleration, which is usually in the format plus or minus g sine theta. Since we know g is 9.8 meters per second squared, and the incline is 7 degrees, so it's going to be sine theta. And it's also pulling the car backwards. And since we're describing this direction as positive, the acceleration will be pulling the car backwards, and thus it will be negative. So the two things we need to find are change in time. We'll also define this position where the car runs out of gas as S0. So we also have S0 initial position as 0. We need to find change in time. As well as final position at when velocity is 0. So we'll start with time, and let's look at the kinematic equations. Which of these allows us to find time where it's the only variable that we don't know? It's the second one. So we're going to isolate for change in t, and that's going to give us V final minus V initial over A. That's going to be 0 minus 35 meters per second over negative 9.8 meters per second squared times sine of 7 degrees. After computing this, the meters cancel out and you'll be left with 1s. The answer to that is 29.3 seconds. So after 29.3 seconds, the car will come to a complete stop. We also have to find, now that we have time, if we put it into the first equation, we have V initial, position initial, acceleration, and the only thing that's left is the final position. So we can easily solve for that. Just plug in everything we know currently. (35 meters per second times the time, 29.3 seconds, plus 1/2 negative 9.8. Negative 9.8 sine 7 degrees, 29.3 squared. Doing the calculations for this, the final position should be 512.3 meters. So in 29.3 seconds, After the car has run out of gas, it should have traveled a total of 512.3 meters before finally stopping.